Hello, welcome back. This is Michael again. This is the first in the series of the teacher commentaries to go with the Joy of Code programming tutorial. If you haven't seen the first few of the episodes that are on the website now, especially episode 3, then maybe you should have a quick look at that, because that's mostly what I'll be talking about today. You'll see here on screen the hedgehog scenario, which is the one that I used for the last episode in the mainstream of the tutorial. If you haven't seen Greenfoot before, then it is worth maybe quickly having a look at the tools it provides. For the Greenfoot environment really has two perspectives on it. There's the student perspective and the teacher perspective. From a student point of view, the goal of Greenfoot is to get graphics on screen and get them moving very quickly, so to get essentially very quick and visual feedback, to have success stories very early on. So from a student point of view, Greenfoot is really a graphical, game development environment. From a teacher point of view, Greenfoot is designed to help you teach the main principles of object-oriented programming. And so there is a lot of design effort has gone into designing the system so that it very cleanly and clearly represents the main principles of object orientation. You have seen that in the episode where we looked at classes and objects here. So from a class hedgehog, we said we can create an object. This distinction between classes and objects is traditionally a very hard distinction to grasp. So if you have a standard environment, if you use something like Eclipse or NetBeans and you program in Java or Visual Studio to do program in C# or something like this. All these environments, what they show you on screen first is essentially lines of code. If all you ever see on screen is lines of code, that is what students will think about lines of code. And that is not what we really want them to think about. We want them to think about classes and object structures. This distinction between a class and an object in a text-based environment is really, really hard to grasp. And so one of the main aims of Greenfoot is to make this these concepts, the very abstract concepts of classes and objects, very visual and experienceable, so that students really get interactions with those. That is really the first main goal that we're trying to get across with this demo. It is really important for good programming principles to start with the big picture principles. There are a lot of other environments that start off with little snippets of code, where you have a textual environment and the first thing you see is little bits of code that look something like this, and you just, this is all you see. You just type in one statement or one if statement or one loop. And creators of those environments often claims this is really easy and students can learn it really easily. That may be true, but it is easy mostly because it avoids all the important and hard concepts. If I only talk about single statements and variables and assignments, of course that's easy. Everyone can understand that in a day. The problem is that it is a dead-end approach, because at some stage you have to graduate from this to the larger, bigger picture program structures, and that is mostly nowadays object orientation. If you start learning with a procedural system or with global variables, or with dirty tricks where you do things not quite in a nice and structured way, then unlearning this and changing is really, really hard afterwards. So what we want to do here is we want to get the hard concepts, the fundamental important concepts, in early and often. There's a teaching principle behind there that says, in your course, identify what really the most important concepts are that you want students to have understood at the end, what they take away from it, and then teach those early and often. In object-oriented programming, the principles are our program is structured by classes. From classes we can create objects. We communicate with objects by invoking methods. Methods can have parameters and return values. Parameters and return values have types. Objects communicate with each other. And these things are the really important things to understand. the small scale things of programming, things like, what does a variable look like? Where does a semicolon go? What does an if statement look like? That is really what programmers at first think is the hard and important bit. Well, it isn't. Just about every student, given enough motivation, learns how to write the syntax of the language. At the end of the day, that is not the hard bit. But not everyone manages to understand object orientation and can write a well-structured program. That is really what we want to do here, what we want to achieve. Where the semicolons go, that can come, the next day, because that's not actually the hard or important bit. Everyone will learn that. So what we're trying to do here is we set the context in which we will start to program. So we are setting the context of what an object is and what a class is, so that when we eventually start program, we will do that in episode 4, the very next episode. So when we actually open the editor and we'll start writing code. When we start to write code, we are doing this in the context of changing or implementing the behavior of an object. So students know from the very early on that when they write code, what they're doing is they're implementing behavior of an object. Having this context is really, really important. So code does not stand alone. The whole worldview that we have when we're programming is that we're defining behaviors of objects. And the rest then is detail. So getting this in first is very important. So what you can see here, the Greenfoot tools, what it gives you, because the classes and especially the objects are visual, it is actually quite easy using Greenfoot to get students to understand what objects are and what classes are. So you can see here the classes. From a class I can create an object. It is pedagogically very important when you demonstrate this that you create more than one object of the class. Don't just create one object. You have to show at least one example of creating multiple objects of a class. That is a very important point that students have to see. Then show methods and method invocations. That is a very important principle is that students have to understand is I can communicate with objects by invoking their methods. Greenfoot makes understanding this really quite easy. You just have to show it the way I have done in that tutorial. So you invoke methods and the object reacts. So there is, the different identity of the object is important as well. We can say that I can either talk to this hedgehog or to this hedgehog, and then the appropriate object will act. Thinking about it afterwards, I probably should have included a method with a parameter. I think that would have been better. There was a chance to introduce parameters at this point as well. I have not done that. That can quite easily be done at that stage. And then I have used return values to introduce types, or the first mention of types. That could also have been done with a parameter instead. Another thing to introduce early is state, saying that every object keeps track of its own state, and you can do that by opening the inspector and looking inside this object and then looking at the values of the fields inside it. And some of the easiest ones to understand and look at is things like the x and y coordinate. And so this is this hedgehog here, which has an x coordinate of 4. So since it faces right, if I get this hedgehog to move now, we would expect that x coordinate to go up by 1. So if I say move to this hedgehog, it has just changed to 5. Or we can also do that with the rotation. Watch the rotation here and then tell this hedgehog to turn left, and now it has points at 270. In Greenfoot, rotation is expressed in degrees, where 0 is facing right, and then it goes clockwise. So 90 degrees is down, 180 degrees is left, 270 degrees is up. So state can be introduced. You don't have to talk very much about it. Much of what Greenfoot gives you is that you do not have to really explain everything to death. Just show it to students, get them to play around with it a bit, and they will get the idea just by looking at the Greenfoot interface. One other important thing is to understand and accept that when you mention a concept, you do not have to fully explain it. You do not have to say everything about it that there is to say. For example, when I mention types, I've shown here that there is an int and a boolean. I have very briefly, and only very briefly in the episode 3 of the tutorial, mentioned those types, said a little bit about it, and that's it. I have not properly explained them yet, and that is okay. It is okay with students to introduce a concept, say a little bit about it, and be incomplete about it. It is what we call a spiral approach, which means we touch on a concept, we explain a bit about it, and then we move on. Then we come back to it later and we explain more about it, and bit by bit, over the course of various days and weeks, we get a fuller picture. There are a lot of teachers, and especially books, who feel they have to be complete. So the first time a type is mentioned, there is then the complete discussion of all types. There's a table of all the types in the language. There's a table with all the operators of the types. That bores students to death. Students cannot, at this stage, distinguish which bit of information is relevant right now and which bit is just there for completeness sake but can be ignored just now. So that all becomes conceptual noise that makes it much, much harder for students to understand the important bits. So it is okay to just explain just enough to get the job done, and then move on to the other thing. Because what we've done here in this very short introduction in episode 3 is we have touched on a large number of very big concepts. That is okay, because we don't expect students to understand everything about those concepts yet. We expect students to get a first overview, a first feel for the main concepts, so that they can work with this environment. But deeper insight and deeper understanding will come when students work more with the environment. One last thing to say is this example, or an example like it, this playing with Greenfoot, experiencing object creation, experiencing interaction of objects and invocation of methods. All this is very important to build up the conceptual model for students, but don't overdo it. You don't need to do that for too long. When it gets it's really important that students get a real hands-on experience, get to do something, be creative very quickly. Of course, with this example here, they can play a little bit, but it is somewhat restricted what you can do with it. You can play for it for 5 minutes. You can make the hedgehog move to the apple and then make the hedgehog eat the apple, but that is almost pretty much it. This is not for students a terribly exciting example. So by all means, use this as an introduction to set the conceptual model, but don't go on too long about it. If you are in a classroom where students can actually do something, I would do this for 15 or 20 minutes and then move on to actually writing code. That is the bit that I will present in episode 4 of the Joy of Code tutorial. This, when students start writing their own code, typing something in, doing something, that is where they get the kick, where they get the excitement of becoming creative and doing something. That is where we want to get to as quickly as possible, because that's when we get them hooked. This example here is important conceptually, but don't spend too much time introducing concepts in an abstract way up front. What we want to do is we want to invert the order. We don't want to explain the concepts first and then let students get experience with it. We want students to get some experience first and then add the theory about it afterwards. Most students learn better that way, so we want to get them, they're dipping their feet in the water very, very quickly. So use this, give an overview over the main concepts for 15-20 minutes. If you are separated in to have a lecture and a lab session, then you may want to do this in the lecture in the first lecture, and maybe you can stretch it out for a whole lecture, or maybe I would probably show a little bit of coding, the episode 4 of the tutorial in that lecture as well. So don't drag it out too long, but it is important to present these concepts first so that when we get started coding, we know what we're doing. And what we're doing is we are changing the behavior of objects. So the principles of objects and classes and methods and behavior should be understood before we get into all the detail of where do the parentheses and the semicolons go. Okay, in the interest of keeping this brief, I'll end here. I will provide more teacher commentary a bit later on when we do a little bit more of the tutorial. If you have any questions or comments, discussion points about what I've said here, please leave them in the comments of the blog, and I will talk to you again in a little while. Okay, thanks for listening. Bye bye.